So, yes, Minashi, you are telling me, na?
Yes, sir.
Can you guys hear me?
Yes, sir.
Okay. So we have to compare this K. We have two values. Either it will be 10 to the power minus 3 and 10 to the power plus 3. So you tell me, is it less than or it is greater than, or where does the K lies? You have this number line. So where does the K lie? Is it less than 10 to the power minus 3? Is it more than 10 to the power plus 3? Or is it in between somewhere here? Tell me.
Less than.
Less than, है ना? So that means obviously in this case the reactant will dominate. The reactant dominates. That means most of the molecules that you will see in the at equilibrium will be of reactants only. What about this next one?
Greater than.
Greater. So what will dominate, reactant or product?
Product.
Product will dominate. And what about this?
In between.
In between. So both will have appreciable concentration. Okay, both will have appreciable concentration. Okay. What about others? Do anyone else have any other doubts? Yes, Mehreen, do you have any doubts from these questions, 10.25 to 10.34, the questions that I gave yesterday? Yes, Mehreen? Okay, Mehreen is not answering. Okay, so as I said yesterday that we will be doing ionic equilibrium in today's class. We will be doing ionic equilibrium in today's class. Ionic equilibrium. Okay. So in ionic equilibrium, first of all, we have to study about ions, है ना? And ions are charged species. So we'll have to look at what comes before ions. That means what are the molecules that we are going to use, what molecules produce ions. We have to first of all learn that. And after that, we will be learning about different types of ions, right? Different types of ions. So Faraday was the first person who classified things into electrolytes and non-electrolytes based on what conducts electricity and what doesn't conduct electricity. If you put the substance in water, for example, let us take paper. So paper, it will not conduct electricity even if you like get paper and cut it into pieces and then you pour it inside water. But if I talk about NaCl, that is sodium chloride, if it is in solid state, then it doesn't conduct electricity, right? It doesn't, no electricity it will conduct. But if I melt it, if I melt NaCl or I put NaCl in water, that means NaCl in aqueous condition, it is going to give me electricity. It is going to give me electricity. Now, on the basis of this, he classified everything into two types, electrolytes and non-electrolytes. So the one whose melt or the aqueous state of those substances, if they conduct electricity, he called them electrolytes. So first thing is that we will write the definition of what is electrolyte. So the substance that conduct electricity in molten state. That means if you melt it, or aqueous state. In both of these states, if it conducts electricity, then it is called electrolyte. It is known as electrolyte. Examples would be NaCl, then NaOH, will also have HCl, KBr. These are examples of electrolytes that will conduct electricity when added in water. Now, for example, if I take NaCl, then it conducts electricity. It means that there should be some charge carriers. There should be some charge carriers which carry the electricity in the aqueous phase. So those charge carriers are obviously Na plus in aqueous phase and Cl negative in aqueous phase. So these are the two ions. These are the two ions. So this is my electrolyte. It's very important. Most people, they confuse. This is electrolyte. Okay. Na plus and Cl negative, these are not electrolytes. These are ions. Okay. These are ions, and NaCl is the electrolyte. NaCl is the electrolytes. Now, based on how well you dissociate, if I take, for example, 1 mole of NaCl and all the moles of NaCl are being dissociated into Na plus and Cl negative, then those are known as strong electrolytes. And the ones that completely doesn't dissolve and they dissolve partially, they are known as weak electrolytes. So we can divide electrolytes into two categories. Okay. The first one is strong electrolyte. The other is weak electrolyte. So they completely dissociate into ions. Strong electrolytes, they will dissociate completely into ions. Some examples will be okay. So you have salt of strong acid and strong base. Then you have strong acid and strong bases. These completely dissociate when you add them into water. Okay. Next is weak electrolytes. So they dissociate partially. Dissociate partially into ions. Examples for these would be organic acids such as CH3COH. Then you have NH4OH. Also HCN. NH3. So these are examples of weak electrolytes. You don't have to remember them. Just you have to remember these points that dissociate. Strong electrolytes, they dissociate completely into ions, and weak electrolytes dissociate partially into ions. Now, simple introduction to electrolytes. Then we will move on to see whenever you see any electrolyte. For example, let us take NaCl. So NaCl, how is it made? It is made from HCl plus NaOH, right? So they will form NaCl plus H2O. Now, if I take any of these electrolytes, they are going to be either acid or base, or they are going to be salt, which are prepared from acid or base, and that is why, first of all, we will learn about the acid-base concepts. What are the different concepts of acid and bases? If we can identify what are acid, what are bases, then we can also comment a few things about the salts made by those acids and bases. So now we will learn about the acid-base concept. Why? Because electrolytes are either acid or bases, or the salt made from acids and bases. Hence, we need to brush up on acid-base concepts. So over the time, there have been a few acid-base concepts. The first one that we are going to study is the Arrhenius concept of acid base. Arrhenius concept of acid and base. Arrhenius concept of acid and base. So Arrhenius had simple definition for acids and bases. He said that acids, what are acids? He said that anything is acid if it gives, acids gives H plus ions in water. Examples of this would be HCl, CH3COOH, H2SO4, right? Next is base. Water bases. He said that bases give OH negative ions in water. So in water was there in the definition of Arrhenius. In water, it should give OH negative ions. So examples will be NaOH, KOH, right? NH4OH, rather not. Which you can also have CaOH whole twice. So these are examples of bases according to Arrhenius. So he said that if you have an acid, that means acid should have a bond with hydrogen, and if you add water to it, then you will get H plus and A negative, and a base, it would have OH group attached to it. On addition of water, it will dissociate into B positive plus OH negative. B positive plus OH negative. And he also had similar definitions for strong acids and strong bases. He said that anything is strong that completely gets dissociated. Okay. So strong acids and strong base gets completely dissociated. He said that strong acids and strong bases are those which gets completely dissociated, and weak acid and bases get partially dissociated. So this was simple concept of acid and base according to Arrhenius. The next concept that we are going to study is of more importance, and you may, and I think you should get some questions on this. Second is, please pay attention, Bronsted-Lowry. Acid base concept. Bronsted-Lowry acid base concept. Okay. So now his was more simpler definition. He said that acids give H plus. That means they will lose H plus. That means acids lose H plus. He said that bases accept H plus or gain H plus. Okay. Is this fine with everyone? All of you, please tell me. Yes, tell me. Yeah, okay.
Yes,
now I'm
sir.
going to write a reaction. You will identify which is acid and which is base. Okay, fine. Let us take an example such as CH3 COOH plus H2O. It is going to give me CH3 COO negative plus H3O positive. So tell me, which is acid, which is base in 1 and 2? Which species losing H plus?
CH3COH.
CH3COH, right? The first one is acid, right? All of you. And which one is gaining H plus?
H2O.
H2O. This is going to be base. Now, You tell me. Now again, you have 1 and 2. Now tell me, which is losing base or gaining base? What is happening with 1? It is gaining, sorry, it is gaining a H plus, or it is losing an H plus?
Gaining.
Gaining. So it is going to be a base, right?
Yes, sir.
What about H3O plus?
It's losing.
Losing. So this is going to be acid. Okay. Now I hope you can see that there is some similarity between these two molecules. Yes or no, guys? CH3COOH, right?
Yes, sir.
Now they have a relationship. Now I just wrote that explicitly, that reaction explicitly, but we have the same reaction going on here because it is an equilibrium, right? Because it is an equilibrium, you have the same reaction going on here. So I can say that this is my base and this is an acid. Obviously, it is a base in its absolute term, but on its relationship with CH3COOH, it is the conjugate base of CH3COOH. Okay, so when you remove the proton from acid, you get a base, and that base is the conjugate base of the acid from which you have removed it. This is the conjugate base, and this is the conjugate acid of H2O. Conjugate acid of H2O. Now, tell me if you have any problem in capturing this thought of.
No, sir.
No, no one has any problem, right?
No, sir.
No, sir.
Okay. Good. So conjugate acid base pairs. So whenever we will have conjugate acid base, they will be in pairs, conjugate acid base pairs. So if you add a H plus to a species, it becomes the conjugate acid of the species, right? Add H plus to make, see, you had a base, you added H plus, you made it conjugate acid. Add H plus to make conjugate acid, and you have to remove H plus to make conjugate base. You have to make conjugate base. Okay. No problem till here? Yes or no? Any problem?
No, sir.
No. Let me give you a few questions. Yeah. So you have to, what will be the conjugate bases for the following Bronsted acids? So what will be the conjugate base for HF? So how to make conjugate base? You have to remove hydrogen. Tell me. What will be the conjugate base for HF? What happened, guys? F negative,
F.
है ना? Because F negative, because if you remove H positive, that means there will be F negative. Okay, what about H2SO4?
SO4 negative.
HSO4
HSO4
negative.
negative. Yeah, HSO4 negative. What about HCO3 negative?
CO3 negative.
CO3 2 negative, no? You have to just
Oh, yes,
like
sir.
from neutral, you have to add a minus charge. CO3 2 negative. Very good. Now, or write the conjugate acids for the following Bronsted bases. NH2 negative. So when you are adding H plus, then a positive charge will come with it, no? So tell me.
NH3.
Yeah,
Positive.
simple. Yeah, just NH3 because it already had negative. You added a positive, you made it neutral. Okay, if you have NH3, now this is
NH4
neutral.
positive.
Yeah, very good. NH4 positive. I'm getting a hang of it. Now, if you have HCOO negative,
H2CO.
HCOOH, right? You have to know these structures also. Aisa nahi hai na? I hope no one thinks that it is the bonds are like this. Does anyone thinks the bond is like this? I hope not. You guys don't know HCOH organic chemistry पढ़ के आ गए हैं. C double bond O carboxylic acid. You remember it now?
Yes, sir.
Yeah, okay. Now, let us look at a few special molecules. Okay. See. H2O. You can add you can add H plus, you can also remove H plus. So let us say you added H plus, then you will get H3O positive. You remove H plus, you will get OH negative. Similarly, you can have NH3. You can add H plus, you can remove H plus. If you will add H plus, you will get NH4 positive. If you remove, you will get NH2 negative. Okay, what else you can have? We can also have HSO4 negative. If you add, then you are going to get H2SO4. If you are going to remove, then you are getting SO4 2 negative. Now, you can also have HCO3 negative. If you add your, HCO3 negative, yeah, HCO3 negative. So if you're adding it, then you will be getting H2CO3. If you're removing it, then you're getting CO3 2 negative. CO3 2 negative. Okay. Similarly, if you can have what else? You can have SH negative. If you add, then you will getting H2S. If you remove hydrogen, you will be getting S2 negative. Okay. Now, these molecules which can add protons and also remove protons, they are known as amphoteric. They are known as amphoteric. So if you see anything which can act as both acid and base, they can act as both acids and base. So if they are removing a proton, that means they are acting as a acid. If they are adding a proton, that means they are if they are adding a proton, that means they are acting as a base. Yeah. And if they are removing, then they are acting as a acid. So substances that can add or remove, not or rather they can add and remove H plus, can act as both acids and base, and they are known as Amphoteric. They are known as amphoteric. Now, tell me, do you have any problem till here?
No, sir.
No. Okay. Now, let us see. We have an acid, Ha. Then what happens? It reacts with the base and it forms A negative plus H positive. Now, if I want to talk about, and if we want to discuss about the strength of an acid, if I want to talk about the strength of acid, then I have to think about this bond. Yes or no? Now, if I can easily, if I should say, if acid easily forms A negative and H positive, then it will be a strong acid or a weak acid. Tell me. Then it will be a, what kind of acid it will be if it easily give H plus? Will it be strong or it will be weak? Guys, tell me. No idea. What does acids do? What does acids do? What does acids do?
Give H plus.
Give H plus. So if something gives H plus easily, then it will be a strong acid or a weak acid?
Strong.
Strong acid, right? Then it will be a strong acid. Now, all of the acid, they are going to form H plus. There is no question about that. The only point of difference in acids would be the A negative ions. Yes or no? Because H plus is going to be same for any acids that we take. Correct?
Yes, sir.
Now, this A negative, tell me, what if this A negative is what is more favorable for us? What is more favorable for a strong acid? We should form easily the A negative ions. Yes or no? The A negative ion should be easily formed, correct?
Yes, sir.
Yes, sir.
Okay. Now, if something has to be easily formed, that means it should be stable or it should be unstable. What can form easily? Something which is stable or something which is unstable? What do you think? Which will be there for a long time? A negative, should it be stable or not stable to form easily? Think and tell me. The A negative should be stable or it should be unstable? Acha, tell me one. If it is unstable, then it will want to be as A negative, or it will want to change its, will A negative want to change, or will it be A negative if it is unstable?
That will want to change.
Okay, it will want to change. So if it wants to change, then A negative has in close proximity, in very close proximity means in its neighborhood, it has H plus ions. So it will react with H plus ions, right? Because it is unstable, and if it is unstable, it would want to change its state. And if it wants to change its state, then it will react with H plus, yes or no? Yes or no?
Yes, sir. Yes, sir.
Yes.
Now, if it reacts with H plus ion, what will going to happen? We will form AH, correct? Hana?
Yes, sir.
That means if the A negative is unstable, it will combine with the H positive, and it will like to stay as AH if it is unstable. But whereas if A negative is stable, then it will not bother the H plus ion. It will let it loose, and we will get more and more H plus ions. So now you tell me, guys, which is more favorable for us for a stronger acid? A negative should be stable or not stable?
Just stable.
Stable.
Stable. I think all of you agree, yes or no?
Yes, sir.
Okay, now one more thing. If A negative is our base, right? And what is the tendency of base?
It accepts H plus. And
To accept H plus. Yes, correct. And this acid is strong, hence this A negative is stable. And since this A negative is stable, it is not accepting and it is not bonding with the proton. That means, can I say that it is a weak base?
yes, sir.
Yes, all of you? You can see that, right?
Yes, sir.
Yeah. Now, we've got to some conclusions here. Strong acids have stable conjugate base and stable and weak conjugate base. And weak conjugate base. Also say strong base have stable and weak conjugate acids. Similarly, I can talk about weak acids have unstable and strong conjugate base. Similarly, weak base will have unstable and strong conjugate acids. Now, these 4 points, I hope these are easily like what I can say. You understand all of these points, right?
Yes, sir.
Also, you can write strong acids easily loses H plus. Again H plus. Okay. So you can do a few more questions. I think we did some questions here, no? We did 2 questions. Okay, fine. So I think you can do one more question. Let me just see that. That will be question number 37. 37 with it. 38 with it. 39. Okay, 39 also we have done. Okay, 35. Question number 35. That is something that we have to. 35. Okay. So this is all about the Bronsted-Lowry acid-base concept. Bronsted-Lowry acid-base concept. Now, there are a few more points that we have to write. Let me before that give you Lewis concept of acid and base. Then we can write about remarks later on. Lewis concept of acid and base. Now, Lewis went further and he defined acid base to more simplicity. He said that acids accept electron pair. That means they are electron pair acceptor. And then he said bases. What are bases? Bases donate electron pair. That means these are electron pair donor. Electron pair donor. So you have A. You can have anything B. Now, if the B has lone pair and can give electrons to A, that means here you will be forming a bond AB. Okay, this will be acid and this will be base. Okay. So how to identify Lewis acids and Lewis base? So for Lewis base, anything with a lone pair, it can act as a Lewis base. Okay. So for lone pairs, you can classify them into two types rather. You can have Lewis base in two types. Some will be neutral and some will be anions. Neutral and anions. So anions, obviously, they will have a lone pair. That means a non-bonded pair of electrons. So neutral species with lone pair. So neutral species with lone pair. So examples would be NH3, which has one lone pair. H2O, it has two lone pair. Similarly, you will have RNH2, amines, it has lone pair. You have alcohols, ROH. This also have lone pairs. Now in anions, there will be various anions, no? Because all of them will have some lone pairs. Cn negative, and this nitrogen and carbon both have lone pairs. Cl negative with 4 lone pairs. You can have OH negative, it can act as a Lewis base with 3 lone pairs, right? So lone pair is the necessary condition. Lone pair is the necessary condition for a species to be Lewis base. Next is Lewis acid. So Lewis acid is a bit more complex, I would say. It has various criteria, but you won't be getting these. You have to keep this in your notes. Okay, wait a second. Yeah. So Lewis acids. Lewis acids. There are 4 ways or 4 types of Lewis acids. The ones with incomplete octet. Ones with incomplete octet. Examples would be molecules such as BF3, AlCl3, right? FeCl3. These are the ones with incomplete octet. Now, anything which has a positive charge will be able to add on electrons, and it will be able to attract electrons. So that means we are talking about simple cations. Simple cations, they will attract electrons, and when they add electrons on themselves, they are acting as Lewis acids because they are accepting a pair of electrons. Simple cations such as sodium positive, calcium 2 positive, Ag positive, right? Hg positive, okay, or Hg2 positive, H positive. So these are examples of Lewis acids. Now, obviously, sodium and calcium, the group 1, group 2 elements, they don't have a higher tendency to accept electrons, so they will be not a good Lewis acid. But if I talk about the d pro electrons and the H plus ions, they have a high tendency to accept a pair of electrons. So these will be stronger. Next is the ones with empty d orbitals. Next are the ones which are empty d orbitals. Examples would be such as silicon fluoride. Now silicon, it has vacant d orbitals. So those with empty d orbitals, they can also act as Lewis acid because they can accept a pair of electron. Examples would be SnCl4, PF5. Okay. Furthermore, you can also have atoms which are connected to more electronegative element. Atoms which are connected to more electronegative atom via multiple bond. via multiple bond, है ना? So for example, now this is going to be interesting. I will show you some examples here. Carbon dioxide, SO2. So carbon dioxide is C double bond O, C double bond O, right? So this carbon has a very high delta positive charge, and that is why it is able to accept a pair of electrons. Now let me show you a reaction in which we have the first case, that is BF3. These examples are important for you. See, if you have BF3 on trifluoride, what is the atomic number of boron, guys? Boron is, what is the atomic number of boron? Atomic number of boron. सब सो गए क्या हो गया?
5.
5 बोलने में आपको इतना देर लग गया. So it will be 1s2, 2s2, 2p1, right? Now I hope you remember some of the hybridization part. So 1, 2, then 1 electron, there will be excitement, and you will have so only 3, right? So all of these 3 will be combined together and hybridized to form sp2, but this p orbital, as you can see, will be vacant. One p orbital is vacant, right? So that p orbital will be exposed like this. This will be the p orbital, yes or no? Right, guys? Yes or no?
Yes.
Then you have NH3 molecule, which has lone pair electrons. So this lone pair will attack on, this lone pair sees that it can place itself in a particular orbital. So it will place itself in the empty orbital of boron, and you will form a molecule. This type of bond will be formed. This type of bond will be formed. And this is okay. So BF3, it is accepting a pair of electron or losing a pair of electron? BF3 is losing or accepting? Tell me, guys, fast. BF3 is losing pair of electrons or accepting pair of electrons?
So accepting.
Accepting, na? Why are you guys not saying Minashi, Razan, Mehreen? You can't see that, Minashi?
No, I can see.
You can see, so you can see also, na, Lewis? This will be Lewis acid. What about NH3? Accepting or losing? Accepting or donating pair of electrons?
Donating.
So this will be Lewis base. Remember this reaction, okay? Remember this reaction. Another reaction is with CO2. You have carbon doubly bonded with oxygen and also doubly bonded with another oxygen. Let us say you react this with OH negative. So OH negative is obviously a base because it has lone pair electrons. Then one of the lone pairs will attack on the carbon. Then you will shift the electrons like this because carbon cannot form 5 bonds. And the molecule that you are going to get is COH, C double bond O, and O negative. Okay, and O negative. So this is how this is going to be our Lewis acid. This is my Lewis base. Any problem here, guys?
No, sir.
Okay. So other than that, let me give you a question. Identify Lewis acid and Lewis base. Okay, so this will be your homework. Now let me just revise all the points that we did about acid and bases. So 3 concepts we learned today: acid, base. The first concept was Arrhenius concept, right? The first concept was Arrhenius concept of acid base. Arrhenius. So what did Arrhenius said? Arrhenius said that acids are those that give H plus in water, and bases are those which give OH negative in water. Then we learned about the next concept, that was Bronsted-Lowry. So Bronsted-Lowry said that acids are those which are H plus donor. So Bronsted-Lowry, they did not have water in their definition. He said that if anything donates H plus to anything, that will be acid. And what will be a base? That accepts H plus acceptor. Then at last we learned about the Lewis acid base theory. So Lewis simplified it to electrons, and he said that anything which is electron pair acceptor is acid, and anything which is electron pair donor is going to be base. Okay. So this is the crux of today's class: 3 concepts of acid and bases. Then tomorrow we will write some remarks, and then I'll study about water, because whatever we are going to add, either it is acid or base, we are going to add it in water. So we have to study about water first, and we have to study the system that is water, and then we'll